Hello everyone, welcome to the first video of the Python baseline tutorial series. Aim of this series and of these tutorials is to get you up and running with writing code as quickly as possible. For this, we will use Google Colab. You will not need to set up Python on your computer. So everything will run on Google. Assuming that you have a Google account, you can go to your Google Drive, create a folder for all the tutorials. You can name it whatever you want. And you can create in this empty folder a new, more Google Collaboratory file. When this file opens up, you can name this file whatever you want. So for example, here we can call it baseline_01, okay? And we can start writing code. For example, you can start, I don't know, let's write x equals 5. So we might get a declaration of a variable x that equals 5 here. You can see that it is connecting, so it might take some time, don't worry. And you can see that there's something rolling around here. This means that it's working. Great, now it has run. You can see the tick box here. And then you can insert a new cell and you can type some other code if you want. And in each cell you can type, I don't know, multiple lines of code and execute them at the same time, either by pressing a play button or by pressing Control and Enter in Windows or in Linux, or Command and Enter in Mac. So throughout all the series of the tutorials, and especially if you are a programming beginner, it is recommended that you type and execute for yourself all the commands shown in this tutorial, even though you can find the code in each video on GitHub. So there will be a link in the description, but make sure that you type and execute for yourself whatever we write here. This is a basic part of learning how to code. Okay, now I'll close down this first experimental file and I'll open up another file that has some guidelines for the first tutorial. Okay, so this is our first tutorial, and you can see that there's a link to the GitHub page of all the tutorials. There's also a link for the exercises regarding this specific tutorial, which is again on GitHub. So if you follow that link, you can find the subfolder with the exercises, and you can find all the exercises for all the tutorials. And in this tutorial, first let me zoom in a bit just to make it easier for you to see. Okay, I think this should be fine. You can see that I have created already some cells that include some guidelines about what we will do in this tutorial, and you can see that I have several lines that start with a hash. So whatever starts in Python with a hash is a comment, which means that whatever is written after the hash and has a green color will not be executed. It's like having no code here. But this is something very nice for us to have in mind. You can comment out lines of code if you do not want to execute them to test how a program would work without those lines, or if you test between two alternatives of two different lines of code, you can interchangeably comment out one of each. We will see those things as the tutorials move on. So let's start with the basic variables of Python and the print command. So integer variables are variables, for example, x equals 5. X is a variable that starts by having a value of 5. So let's run it. Let's wait for it to connect. Nothing to worry about. This happens. And after that, we can go to the variables space that Google Colab provides us. And you can see that we have now a variable x that has a value of 5 and the type is integer. Of course, we can change the variable value anytime. So initially it was 5, but now x is 4. And we can also assign other variables. So for example, let's see, y equals 5, or x equals 5, y equals 4, and we can do between those two variables basic operations, like for example addition, subtraction, as we will see, multiplication, division, etc. So now you can see that we have a new z variable, and since this is the summation of two integer variables, z is also an integer variable. There's also a cool trick to print things out. So if we ask Python to print x, you can see that it prints the value of x. So now it knows that x is a variable that has a value of 5, so it prints 5. If we ask it to print y, you will see that it prints 4. But since we first asked Python to print y, it will show first 5 and then 4. And we can directly ask Python to print x, for example, minus y. So now here we have the subtraction. 5 minus 4 is 1. I should comment that we do not need to have those spaces in between signs and symbols, but I do it just for clarity, for visual clarity. Okay, it's not necessary though. Then we can have, for example, x times, this is multiplication, y, or we can have division, for example, x divided by y, and we can have the power, x to the power of y, which is in Python written like so. Okay, so now we've seen that we can assign variables like so. Sometimes we may need to assign multiple variables to multiple values to multiple variables, and Python allows us to do it this way. For example, we can say that x equals, I don't know, 7 and y equals, I don't know, 9. So now you can see that if we run it, x and y are getting updated with the new values. So now this cell changes whatever we have put earlier on. And you can see that we can do it in one line of code, and the semicolon just indicates to Python that we are using a new line. It's as if we were writing on a new line. We can do it another way as well. So we can use x comma y, again spaces are optional, equals, I don't know, 5.8 or comma 8, sorry, or whatever. So the first part on the left side of the comma will correspond to the left side of the comma after the equal sign, and the right to the right. So this is another way of assigning many values to many variables within the same line. Okay, so now let's talk about floating variables, which are like as integer variables, but they do have some decimal component. You can see now that we have used this decimal separator here. You can see that automatically Python has assigned a float type to it. And we can have a y, for example, that's 5.6 or whatever, and we can do again basic operations. For example, actually, let's assign the, for example, multiplication or addition. Let's make it easier. So z now will be x plus y. So here you can see that z has become a float now that both components are floats. However, if we add a float to an integer, so for example, if y was like 5 or whatever, you can see that z would be still float. And actually, this is what this line says. So let me just bring it here. Okay. So if we add an integer with a floating point value, we can have a floating point value. This does not make too much difference because variables, numerical variables, arithmetic variables are treated the same way in Python. Now let's move on to a very important type of variable, the string variables, which is the way to represent text in Python. For example, if we instantiate a string variable like so, so my name is, for example, Alice or whatever, you can see that we have initialized an s variable that is of type string, that's its value, and has 17 characters. So if you count one by one the characters, including spaces, including period or exclamation or whatever, or whatever symbol or whatever character, it counts up to 17. We can also use, instead of single quotes, we can use double quotes, and we'll have the same result. So you will see that it's still a string with the same value. However, I prefer, and you can optionally do that or the other, to use single quotes whenever possible, just to make it clear for me to see. Okay, so now if we have two strings, for example, let's split this in two. So S1 will be like my name is. Okay, let me take this component and do S2 equals, I don't know, Alice, period. Okay, so if we now try to, let's say, add two string variables, so now you see that we have S1 and S2, we can create a new variable that's like S equals S1 plus S2, which is the concatenation of the two string variables. So S will actually be, let's print it to see what it will be. If we print S, you can see that it is the concatenation of the two, and you can see here that is a space that's very convenient. If we remove it, you can see that it's not that pretty anymore. So if we use it, you can see that we concatenate something. The first string ends with a space, so the concatenation is looks nice. Now there's another. Of course, you can do like multiple additions, so you can add S1 again. Does not make too much sense, but you can add however many you want. And this somehow provides a hint about what multiplication will be. So since addition is concatenation, if you try to multiply, so if you say that S equals 3 times S1, so multiply a string with an integer, and if we print S whenever we need to print S actually, so here we need to print S again, you can see that it just concatenates 3 times S1 to itself. 1, 2, 3. So it's 3 times, like adding S1 3 times, which is like what we will do with numbers. 3 multiplied by whatever is like adding whatever 3 times. Other operations have no meaning, so let's produce our first error. So if we say that S equals S1 times S2, for example, if we try to multiply two strings, whatever that might mean, you can see that we get an error, which is a type error that says that we cannot multiply sequence by non-integer of type string. So you cannot multiply string with something that is not an integer. And for us to remember, let's put this in a comment and comment this line out as well. Let's run it again just to keep things clear, and we can see that if we try to run this, this is the error that we get. Okay, so now let's move on to Boolean variables. Boolean variables are logical variables, so you can have B to be true or false. So here you see that B is a Boolean variable that has a value, a true value or a false value, and actually that's the two values that Boolean variables can have. So we can have B equals false and A equals true, and then we can do some logical operations between those two. For example, we can print to see what happens if we have like B and A. So if we have B and A, you see that we have false. Why? Because in logic, if we have something that's false and something that's true, then the result is false. You cannot have both things being true at the same time. So for example, if B was like I'm hungry, and A is like I've just eaten a lot, so they cannot both be true. One should be false of the two. So you cannot have one and the other, both be hungry and at the same time have just eaten a lot, or something like that, along those lines. You can also have the OR operator, logical operator. So OR has one of the two has to be true. So either I'm hungry or I have just eaten a lot, for example. So either I'm hungry or I have just eaten and I'm not hungry, which is what the example needs to say. And also we can have the negation, which is like not B. So if B is true, and let's write down B, so you can see that if B is false, not B is true, and vice versa. So this just reverses things. This seems to be a very simple topic, Boolean variables, but it's very deep. We're not going to go through it, but just keep in mind that it can happen like so. And also keep in mind that Boolean variables do also have a numeric representation, so an arithmetic representation. So for example, if we try to add, and let's see what happens, B plus, I don't know, 4, then you can see that we have 4, and since B is false, it's interpreted as 0. If you remember, A is true, so if we do instead like print A plus 4, you can see that true actually results to 1 when it comes to numerical operations. Okay, so this is something to keep in mind. Boolean variables are translated to integers whenever they are involved in numerical operations. Okay, so now we have seen integers, floating points, strings, and Boolean variables. And we also, if we need to identify the type of variable, there's actually a function called type. So if we print the type, which is a function, and you can see that it has a different color because it's a Python function. And if we type, for example, A, we know that A is a Boolean variable here. What we will get, it will print us that it's a class Boolean, so the type is Boolean. Again, if we try to do it with X, I think it was float. Yeah, last time we've checked, and I think Y is like an integer. Last time we checked, possibly. Sure, and S will be a string. Okay, so type gives us the type, and also we can change between variables. So for example, we've seen that Y is an integer, but if we say, for example, Y1 equals float of Y, and if we print Y, it's printed out as, print Y1, you can see that it's printed out with a decimal component. So you can see that it has been converted to float. On the contrary, if we do, like, for example, let's print X to remember what it is. So X is 4.5. So now that's interesting. If we do the same thing, X1 equals integer, so int, we try to convert X to integer, and we print X1, as you would possibly imagine, we lose the decimal component. So it's rounded to 4. You can check out what would happen if we had like 4.6 or 4.9. Would we still lose the decimal component, or it would round to 5? This is something that you can check on your own. Okay, so another thing that we can do is we can actually translate a variable into a string. So if we do like X string equals str, that's the function of X, and let's also print it to see what it looks like. You can see that it looks like that, but it's actually a string. So if we check out its type, you can see that the type is a string with 3 characters, 4.5, that's the 3 characters. So just to make sure, we can check out the type of this variable, and it will end up being a string. Another important function, let's say, of strings is that they are able to know whether they contain a digit. So for example, let's initialize a string that's like, I don't know, my name is Bob, okay, and let's check if this is digit. You see that it outputs false. So parenthesis here, if you do not ask Python to print something, we could call up actually to print something and you just throw it in without assigning to any variable. So we do not say that here that, for example, x equals that. You see that it just outputs, it prints the result here, just for quick check. So this is false, and let's keep this so as to remember it. But if we like type, I don't know, 4.5 dot is digit, but if we type, for example, I don't know, 4 dot is digit, then we see that it's true. Okay, so this is a way to check if you have a digit in the form of a string. You can see that it does not work even if it has a space, so it needs a clear non-decimal digit. So this is false as well, so it needs a digit. And let's also remember that this one is true. Okay, so the last part of this tutorial is to talk a bit about some special, among very many, string functions. Let's talk about the split, replace, lower and upper function. So let's start by declaring a string of a special type. So let's say that this string is separated by hyphens, for example. Okay, so here we have this string, and since the string is separated by hyphens, let me also add another space here. We can split it. So if we do, for example, split, let's assign this variable here to s dot split, and we indicate what we want to split at, so a hyphen. This will allocate the hyphens and split strings to those positions. So if we print the result, we will see that we get something that we'll see in the next tutorial. So this is a list, but you can see that it includes the components split by what we have indicated. We can also split not only with a hyphen, but also with the spaces. So if we can ask Python to split it to space hyphen space. So this will create a slightly different result. You can see that there are no spaces here. It's only strings on their own. So, or we can ask it to just remove the first space. So you can see that the space after the hyphens remains. Okay, then we can replace. So if we replace, for example, s.replace, let's ask Python to replace wherever we have a hyphen space, replace it with, I don't know, star and equal or whatever, just to, you know, just to make something that's clear. So now if we print this, you can see that it's a bit messed up because it has replaced whatever we asked it with whatever we asked it. Two other interesting functions are lower and upper, and let's just print directly here. So if we say s.lower, you will see that it will print the string without any capital letter. So all capitals, T in this case, becomes lowercase. Contrarily, if we do upper, all characters are gonna go to uppercase. So this is the first tutorial. You will be able to find this code on GitHub. and you can also try out for yourself the exercises that relate with this first tutorial. Bye for now.